Okay, this is question 34 of the exam practice medley. Now, this is the question I predict. This will be in the January 2020 exam, okay, because this wasn't in the June 2019. And I'm sure this is going to come up. But will it be in this format? I don't know. Sometimes you might get a bridge, and then or you get those curly line, which is to say that this is the uniformly distributed load. It might just be on one side of the bridge, okay? So be careful. But you will find later on in the exam practice medley that there is a questions on this version as well. So make sure you practice both, okay? So I mentioned the UDL, the uniformly distributed load. So let's start with this first. So what they tends to do is that to make the calculation easy is to say that this is all uniformly distributed. This force of 20 newtons per meters is uniformly distributed. So what that means is the force is going to be acting midway of this curly line. So from there to there is 5 meters. So therefore, at 2.5 meters, that's where the force heading downwards is where you're going to draw. But what is the force at this point? Now, they have tricked you here. Okay, that would means that this exam is going to get much bigger marks value because it's Newton per meter. Now, some questions, they just give you UDL to be, say, 100 Newton. And then that arrow will be 100 Newton. However, it's 20 Newton per meter. And from here to here is 5 meters. So therefore, this here is actually 20 lots of 5. Yeah? So that means it's 100 Newtons that you need to use. Okay, so now look at the question. Calculate the reaction force at point B. Now, just remind you the reaction force. So if this is the support, the force will be acting downwards, right? So therefore, the reaction force by this pole here will have to be opposite because remember, it's in equilibrium. Okay, so it will be equal and opposite. So therefore, this reaction force you're trying to calculate at B point, so reaction force at point B will be pointing up. Okay, so to find this point, we need to take moment. So this is a moment question. Okay, so we take moment at point A. So this is your pivot. So imagine this thing can pivot round at this on this point. Okay, so the first step, in fact, I already earned some marks here, but your first step, number 1, is to take, and you do need to write this down in the exam to tell the examiner about A. This is the language in English we say, not on A or in A. Take moment about A. So what you do is anything pointing downwards, that means the clockwise movement, you put it to one side of the equation. Anything that is the anti-clockwise movement, you put it on the other side of the equation. So you can see the only one arrow that is going anti-clockwise, which is on this side, is this bit here. Whereas this 2, this is the only moment that we need to work out, is the clockwise version. Okay, so remember, moment is given by, so this is useful if you write moment is given by the force times distance. Okay, so force times distance. Remember, we're not taking moment about B, so it's starting from here. The distance is from here to here is 2, so it's 50 Newton times 2. Add from there to this force is 2.5 meter times by the force and equal to the anti-clockwise movement, so which is from there to there, 5 meters times RB. Okay. So, in other words, we can tidy this up and say that this is 100 at 250 equal to 5 RB. We can add that together to get 350 equal to 5 RB. How do we get rid of the 5? Well, it's multiplying, so I divide this side by 5. I must divide this side by 5, leaving you with just RB on one side of the equation. And so the reaction force, therefore, is 70 Newton. And that is your 7 marks.